So far, we have been discussing different kinds of models in at risk, some of which involved simply setting up the model and analyzing it and seeing what the output values, how the output values change. Uh, like for example, airline maintenance of systems model. You want to see um, how often we need to schedule routine maintenance to see when the first failure will occur. So it's more like a discovery kind of uh, analysis. And same in the case of financial models like collateralized debt obligations or uh, risk involved in investments. But we also looked at models where we have to analyze and make a decision. For example, um, in the movie pass model, we have a decision to make, like how much should we charge for our subscriptions. And then, of course, there were models of time series type where we are simply trying to predict what the future will be like. In this chapter, we're going to be looking at models where we have to make a decision. Uh, it may be a decision as to how much to produce, or in the case of pricing model, what should be the price at which we sell our product, and things like that. So that's the focus of this chapter, and there are some new concepts that we will be dealing with, and we're going to be looking at all of these different concepts from a single case example, and that involves airline seat pricing uh, problem. So here we call this kind of seat pricing model as revenue management pricing. So the idea is to set the prices in such a way that we maximize revenue. Okay, so revenue management pricing is to look at different classes of uh, price tiers, if you will, and then what is the best price at each tier. So best price for seat. What are the factors that determine the price? Well, it depends on the observed and the predicted demand. So what do we predict our demand is going to be like at different price levels? So uh, and how do you come up with the best price and the tiers? How many tiers should you have, and what should be the price for each tier? And here we're going to make some assumptions, and that our demand for lower fare class will arrive before the demand for the higher fare class. So that's a simplifying assumption. So your lower fare seats will get sold out before before we start selling the higher fare class. Then we're going to consider definite sale of lower fare against the expected revenue of higher fare. So that means because the lower fare demand comes early, okay, now the question is, do we sell a given seat at the lower price, or do we keep it aside in the expectation that that seat can be sold for a higher price at a later time? So that is the dilemma, that's the trade-off that we are looking at. So so one principle is, and that's what we call as Littlewood principle or Littlewood pricing, is that you keep accepting the lower fare demand and keep selling the lower fare demand until the expected revenue from the higher price fare, okay, because that's an expectation, it's a future event, okay, and that expected revenue from the future sales is at least as much as the definite sale of that lower price model. Okay, so let me give an example. Here, suppose if you have two classes, so you have the higher class is $300. Okay, forget about these mean and median. We'll come to that in a little bit. And the lower price is $100. Okay, so if a demand comes for Q class, definite demand, so we can sell it and we can get $100, or we can keep the seat aside for a Y class fare, $300. Okay, but we can do that only just as long as the probability of selling this is at least a third. If the probability of selling is a third, then the expected revenue is 1/3 times 300, which is 100, which is the same as Q class. So if the probability of selling Y class is more than a third, okay, at least 1/3, then it makes sense to hold that seat and not make the sale at the $100 price level. But if that probability is less than a third, then it makes sense to sell the seat at $100. So this is the kind of trade-off that we have to look at, and that's the principle behind Littlewood pricing. The expected price of future sales at a higher price is at least as much as the definite sale at the lower price. So that's what we're going to be looking at, and here we are going to look at this example. And let's set up the first model with these parameters, and we're going to we'll look at this example in the next video.